In this class, we are going to discuss very interesting definition in group theory, and that is nothing but order of an element. So given a group G and element in G, we are calling it as A. Order of that element A is actually nothing but the least positive integer n. Note that we are looking for a least positive integer n such that a raised to n should be equal to e. Remember, e is the identity element of the group. So as the group changes, that identity element will also change. For example, in Z6, it will be 0 bar. In U10, it will be 1 bar. And in Z, it will be 0. And also note that a raised to n is actually nothing but a multiplied by a multiplied by a, so on n times. And when I say multiplication, it is actually the binary operation in group G. So here in case of Z6, a raised to n will be a plus a plus a, and that plus is modulo 6. Alright, and whenever I say in terms of in the group U10, then that a raised to n will be a multiplied by a multiplied by a, but the multiplication will be modulo 10, right? And in case of integers, that is z, a raised to n will be simply a plus plus a, and this will be continued. Okay. And if no such integer exists, then we say that the order of A is going to be infinite. So let us try to find order of some elements in some groups. So we will take Z6, U10 and Z. Note that order of the identity element. Can you guess what will be the order of the identity element? Let us say if I take 0 bar from Z6, so what we are looking for? We are looking for a least positive integer n, let us say, such that 0 bar raised to n should be equal to the identity element of Z6, and that is nothing but 0 bar again. And if you think properly, this least positive integer n will be nothing but 1, right? 0 bar raised to 1 is going to be 0 bar. Same thing in U10, so 1 bar raised to what is equal to 1 bar? That is again going to be 1. And again in case of Z, 0 raised to what is equal to 0? I mean, we are looking for a least positive integer, right? Such that 0 raised to something is equal to 0, and that is also 1. So note that identity element has order 1. So we will not find the order of identity element because we already know now that the order of identity element is 1. So we'll simply write here order of this 0 bar is going to be 1, and the order of element is denoted by O of A. Order of element A is denoted by O of A. So here order of 0 bar will be 1. Now let us find order of 2 bar, right? So what I will do is I will start taking the positive integral powers of 2 bar, right? Because we are searching for a least positive integer such that 2 bar raised to that should be equal to e, but e in our case in Z6 is nothing but 0 bar. So 2 bar raised to which least positive integer is equal to 0 bar, that is what we are looking for, right? So 2 bar raised to 1 will be 2 bar. 2 bar raised to 2, remember, that will be 2 bar addition modulo 6 2 bar, because the operation in Z6 is addition modulo 6, and this is actually nothing but 4 bar. 2 bar raised to 3 will be 2 bar plus 2 bar and plus 2 bar once again, but that will be 6 bar. But remember, 6 bar in Z6 is 0 bar. So we have found out the least positive integer such that 2 bar raised to that is equal to 0 bar, and that is nothing but 3, and therefore order of 2 bar is 3 in this case. Similarly, we can find order of rest of the elements of Z6, which I'll leave it to you. Now moving towards the next example. Now here as well, this order of 1 bar is going to be 1 as it is the identity element. Now let us try to find the order of 3 bar. So we'll start with 3 bar raised to 1, and we will see when do we get the identity element on the right hand side. But note, the identity element of U10 is 1 bar. So on the right hand side we should get 1 bar. So 3 bar raised to 1 is actually 3 bar. 3 bar raised to 2 now will be 3 bar multiplication modulo 10, 3 bar, and that is nothing but 9 bar, which is not 1 bar, right? So now we will move towards next power of 3 bar. So 3 bar raised to 3 will be 3 bar multiplied by 3 bar multiplied by 3 bar, right? 3 times. But this value is already known to us, that is nothing but 9 bar multiplication modulo 10, 3 bar. So 9 multiplied by 3 gives us 27 bar. But note, since we are in U10, this multiplication is modulo 10, and this is exactly same as 7 bar. Still, which is not equal to 1 bar. So we are supposed to take next power of 3 bar, and that is nothing but 4. So 3 bar raised to 4 by laws of indices is 3 bar raised to 2 multiplied by 3 bar raised to 2. So 3 bar raised to 2 do have value 9 bar. We have already found it, right? 3 bar raised to 2 is 9 bar. So we can directly use it. So 9 bar multiplication modulo 10, 9 bar. And 9 nines are, we have 81 bar, but 81 bar modulo 10 is going to be 1 bar, and that is nothing but the identity element of U10, and therefore order of 3 bar is going to be 4. Similarly, we can find order of rest of the elements, which I leave it to you. Now for set of integers, the order of identity element, that is nothing but 0, is going to be 1. Now let us pick one element of Z and let us try to find order of it. I pick 3, you can pick any integer obviously. So let us find what the powers of 3 comes out to be. Note, the identity element of Z is 0, so we have to continue the process until we get 0 on the right hand side. So 3 raised to 1 will be 3, 3 raised to 2 will be 3 plus 3, because binary operation on Z is plus, right? So this will be 6, 3 raised to 3 will be 3 plus 3 plus 3, that is going to be 9, 3 raised to 4 will be 12, right? By doing similar calculations, 3 raised to 5 will be 15, 3 raised to 6 will be 18, and if you observe properly, this 6 is actually nothing but 3 multiplied by 2, this 9 is 3 multiplied by 3, 12 is 3 multiplied by 4, 15 is 3 multiplied by 5, this 18 is 3 multiplied by 6. And if you observe the pattern, whatever power of 3 we take, we will get an element. For example, 3 raised to 7 will be 3 multiplied by 7, which is 21, 3 multiplied by 8, 3 raised to 8 will be 3 multiplied by 8, that is nothing but 24. And as we observe the pattern, the number on the right hand side is going on and just going on. I mean, it is increasing, right? So 3, 6, 9, 12, 15, 18, then 21, 24, 27, 30, 33, and so on. So we will never get 0 on the right hand side. And if this thing happens according to definition, if no such positive integer exists, then we say that order of A is infinite. And therefore, For this particular example, the order of 3 is going to be infinite. In fact, order of all the elements in Z is infinite except one element, that is nothing but the identity element 0.